Hi, in this video, I will be showing you problem number 15 from chapter 7, section 1. It is also a problem in the practice exam for chapter 7. Evaluate the integral ln of x the whole square dx. So we are going to use integration by parts, which is integral u times dv equal to u times v minus integral v du. So in this problem, you have to look at the integrand and decide what expression is a good choice for u and what expression is a good choice for dv. So we will pick u equal to ln of x the whole square and dv equal to dx. So we are picking ln of x the whole square as du and then dx as dv. So now you differentiate the u, so which is ln x the whole square. So you have to apply chain rule. So it is twice ln x times derivative of ln of x, which is 1 over x, inner derivative. Outer derivative times inner derivative. Now dv is dx, so v is simply x. So we have du equal to 2 ln x divided by x and v equal to x. Now let's consider the integral ln of x the whole square dx, which we wrote as u times dv. So applying this integration by parts rule, that is uv minus integral v du. So what is u? U is ln of x the whole square, v is x, minus integral v, which is x, du. So du we have to take from this expression, which is 2 times ln x divided by x dx. So here you have to add the dx. So x and x here cancel out. So here ln x the whole square times x, so we'll write that x in front, minus integral, then 2 can be taken out of the integral sign, ln x dx. So I'm going to call this as x times ln x the whole square minus 2 times I1, where I1 is this integral ln x dx. I'm going to evaluate that separately and then plug it back into step 1. So let's evaluate I1, which is just integral ln x dx. Again we are going to apply integration by parts. So we'll call this function as u and this function dx as dv. So applying integration by parts, so it looks like u dv. So u equal to ln x and dv equal to dx. So maybe we want to call it a different letter. So you don't want to confuse with the original one that we picked for u and dv. So it is d uppercase u, derivative of ln x, which is 1 over x dx. Integral of dv is v, which is simply x. So I1, which is also in the form u dv, is by integration by parts. So uv, uppercase u, uppercase v, minus integral v du. U is ln x, v is x, minus integral v, which is x, du, which is 1 over x dx. So it is going to be x ln x minus integral of 1, which is x. We'll take care of the constant at the end of the problem. So the given integral I, which is integral ln x the whole square dx from step 1, is x times ln x the whole square minus 2 times I1, but we evaluated I1 in the step 2, which is x ln x minus x times ln x minus x. Don't forget the parentheses because 2 must be distributed over. Don't forget the constant of integration as well. So in this, you notice when you distribute the 2, it's 2 times x ln x with the negative signs, and then this will be a plus 2x plus c. So the given integral ln x the whole square dx finally becomes x ln x the whole square minus 2x ln x plus 2x plus c. Hope this video helps.